Hey guys, here's the day 9 homework video. I know we've done many of these in class. Just fast forward through the ones that we already did until you get to the ones we haven't done. Assuming you need any help at all, assuming anyone's even watching these videos. Okay, anyway, so what are we going to do? I would multiply through by 3 first. Just get this 29 out of my way. Multiply through by 3, that'll clear the denominator for you. Yeah, okay. That works. Okay, so it's 2 to the x minus 2 to the negative x equals 12. So it's probably as good a time as any to go ahead and do a u substitution. So you'll say let u equal, it's going to be the 2 to the x. And then if you do that, you'll have a whole new equation where you have u minus u to the negative 1 equals 12. And then what you're going to want to do from there is multiply through by u. And there's 2 ways to think about the reason why. Maybe the cleanest reason is to say, well, all right, this will be u squared. But we're going to clean this up. That negative power, if you multiply by the corresponding positive power, then when you multiply an exponential by an exponential, you're going to add the powers. So if you had -1 and a +1, you'd add and get 0. And then that turns this back into a constant. It just becomes 1. And that's a good thing. We don't really want negative powers. So you can turn those powers positive again by just multiplying through by the opposite of that. Actually, I guess you're trying to get 0. But now we also get a 12u over here, and we now have all the pieces of a quadratic. We've got a quadratic term, linear term, constant. So now you just pull all those terms together on one side. You've got your u squared minus 12u minus 1. And then, you know, somewhat frustratingly, you cannot just solve by factoring. So you have to bust out the quadratic formula. Quadratic formula, of course, being u equals negative b plus or minus square root of b squared minus 4ac all over 2a. So negative b would be positive 12 plus or minus square root of 144 minus 4 times 1 times -1, so really plus 4 all over 2 times 1, so 2. So that's 12 plus or minus the square root of 148. Now 148, you can divide that by 4 and you'll be left with, goes in 3, 2 left over, so 7. 37 is prime, so we can see the only way we're going to break down a 148 is as 4 times root 37. I mean 4 times 37 all over 2. So that's going to be 12 plus or minus 2 root 37 all over 2. And just be super careful now, because so many kids forget this, but we are dividing the 12 by the 2 and the 2 by the 2. That 2 is dividing both of those factors. And I should have said both of those terms. That's what I meant. But to really drive the point home, you might break this down and say, listen, it's 12 over 2 plus or minus 2 root 37 over 2. They both need to cancel and or reduce. So there's your 6 plus or minus root 37. So those are our values of u. But nobody cares about the u value. We want the x value. So remember that we let u equal 2 to the x. Yeah, 2 to the x. So that means we want to substitute those u values back in over here and say 6 plus or minus root 37. And then, of course, to solve, we just take the log base 2 of both sides. So it turns out that x is going to equal the log base 2 of 6 plus or minus root 37. And then one final thing to remember, obviously 6 plus root 37 is a positive value, so that's fine. The log is happy with that. But 6 minus root 37, well, root 36 would be exactly 6. So obviously root 37 is a little tiny bit more than 6. So 6 minus root 37 is negative. And that means if we try to take the log of it, it's not going to work. So actually, that's got to go. And we see that our only solution is the log base 2 of 6 plus root 37. And that's it. So there's a problem. Let's do another. So since I went into a ton of depth on this problem, I will go into much less depth this time. And hopefully that'll be okay. Yoink, 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 yoink. Let's see if I can fit it in here. There seems to be enough space, except I'm living right here about, I bet. So I can't put anything over there because that's me. Here I am. So here we go. Multiply by 2. It equals 6. This question is like so close to exactly the same as this one that I should really be able to just burn through it. We're obviously going to do a u substitution and get u minus u to the negative 1 equals 6. We'll multiply through by u to get a u squared. This will be 6u. Subtract it. I'm going to do that now. This guy's going to go to 1 equals 0. Again, you're just looking at a quadratic, so solve it. You get u equals negative b plus or minus the square root of b squared minus 4 times a times c, so plus 4, all over 2 times 1, so 2. So that's 6 plus or minus root 40, aka 4 root 10, aka 2 root, I guess I meant aka root 4 times 10, so 2 root 10 all over 2. So I'm getting 3 plus or minus root 10. And again, root 10 is just a smidge more than 3. So the minus version here is going to be negative. So we do need to throw it out. So you should show this work where you say, all right, if u is 2 to the x and u is the 3 plus root 10, then that means obviously x is only going to be log base 2 of 3 plus root 10. It can't be 3 minus root 10, because that would be the log of a negative, and that's undefined. Okay, next. Let's make this a smidge bigger. Let's make it a lot bigger. Okay. 31 is the same, honestly, really, really similar. You get e to the x plus e to the negative x equals 8. U substitution now, I guess. U. Yeah, it'll be u plus u to the negative 1 equals 8. You multiply through by u, you get your u squared. I'm going to subtract the 8u from both sides again. This turns into 1 equals 0. It's still not a factorable quadratic, so we're going to use quadratic formula. Negative b plus or minus b squared minus 4 times a times c, so minus 4. So it's going to be 60 all over 2 times a, so 2. 8 plus or minus root 60. Is that divisible by anything? Let's find out. It's a 2 and a 30. It's a 2 and a 15. So there's a 4. 15 is just a 3 and a 5. Prime factorization trees, that's what I did here, if you forgot. Prime factorization trees can be useful when you're breaking down radicals. I guess I've never talked about that really. But by breaking this down to all of its prime factors, we can see that we've got 2 2's, which would make a 4. But 1 3 and 1 5, just put that back together to make a 15. And then you know you can break down the 4, but the 15 definitely can't break down any farther because its only factors are 3 and 5. So this is a pretty secure way to quickly reduce a radical if that's something that you haven't been so good at. So that's 2 root 15 all over 2. So guess what that is? That's 4 plus or minus root 15. But guess what? Aha, slightly different this time. Root 15 is actually a little less than 4. because it's root 16, that would give exactly 4. So this time both the positive and the negative, I shouldn't say it like that, both adding and subtracting are going to be valid answers for us. By the way, what are the valid answers? Well, this time it's e to the x. So everything before was a log with a base of 2. This time we're going to take a log with a base of e, and that means we're going to generate natural logs. I'm going to write my two solutions separately from one another. I'm going to say it's the ln of 4 minus root 15. And then it's also the ln of 4 plus root 15. And you don't have to split them. If you just did one expression that contained a plus or minus, that would be fine. I'm just listing them separately just to even more reinforce the idea that this time around we really do have two solutions. Neither one was extraneous. Let's do 32, which is different, kind of. I guess we're just going straight to a U substitution, eh? This would be 2, assuming we've let U equal 2 to the x, e to the x. So it'd be 2u squared plus 5u minus 3 equals 0. And then this guy is mercifully factorable. So 2 times 3 makes 6. So if I go 2u and u, I know the factors of 6 that will give me 5 are 1 and 6. Oh, wait, it could be 2 and 3. You have to actually be careful with 6. When you've got 6 and you're trying to get 5, it could actually go 2 different ways depending on the signs. So be careful. We don't have a 6, we have a negative 6. So if we're after a 5, actually a 2 and a negative 3, that doesn't make 5, that makes negative 1. So we do want a 1 and a 6. And if we want a positive 5, we want to make sure the 1 is negative and the 6 is positive. But those are our target values for our inner and outer products. So for an outer product, let's get the 6 by just plopping a 3 here, a plus 3. And for our inner product, we'll go for the negative 1 by plopping a negative 1 right there. There, we factored. Not too hard. That's going to generate a u that equals positive 1/2. This guy's going to generate a u that equals negative 3. And again, if u is equal to e to the x, then we have e to the x equals 1/2, which gives us an x value that is the ln of 1/2. And that's fine. That's a positive value. So that's going to be one of our answers. This guy's negative though. So again, e to the x, if it equals negative 3, generates an x that equals the natural log of negative 3. And that can't be. So we huck that in the garbage and we keep our only answer, which is this. So we would say x is an element of the set that contains the ln of 1/2. Ugh. All right, wait a minute. It just dawned on me. Did you guys know that 1/2 could, of course, be expressed as 2 to the negative 1? And then you could pull out the negative and call this the opposite of the ln of 2. So that would be not a different answer, just an equivalent answer. It's the same as this, just expressed differently. And again, and I mentioned that because I think I warned everybody. I don't remember if I warned all 3 classes. I hope I did. But on the quiz, I do intend to maybe have some questions like this, where maybe I'll present you with multiple answers and I'll say, pick all that are equivalent. And so you better recognize that the ln of 1/2 and the opposite of the ln of 2 are the same. And so if you're presented with sort of multiple check boxes and multiple different expressions, if one of them is the ln of 1/2, you better check that. And if another one down here is negative ln of 2, you better check that. And maybe there'd be more, who knows? But I hope you understand that. I'm basically asking you just to break these things down if you can. Moving on. Ugh, same old stuff. Okay, you're gonna let u equal e to the x. That's going to make a u squared minus 6u minus 7 equals 0. And this guy's factorable again easily. You get a u minus 7. You get a u plus 1. So again, if u is equal to 7, and if u is equal to negative 1, but if u is equal to e to the x, then you just take the ln. So again, you get the ln of 7. Over here, however, you get the ln of negative 1 as your x value, which again, you can't do the log of a negative, so that's extraneous, which means your one and only solution is x is an element of the natural log of 7. And 7 being prime, there's certainly no other way really that I could express this, or is there? Is there? I mean, I guess if I really wanted to be annoying, I could do the ln of 14 minus the ln of 2. And you guys, I hope, would look at that and go, oh, that's just quotient rule, sir. So that's the ln of 14 divided by 2, that's 7. So yes, that is equivalent to this. Now it's decidedly worse. It's not clean, it's worse. But if I was just asking you to identify equivalent forms, then technically this and this are worth the same. They are equivalent forms. All right, by the way, I'll only do that once on the quiz. And then every other time you can just give me whatever answer you've gotten. Let's move on. Share. All right, I can't even pretend that this is any different from any other problem. So, you know, what would we do? We would let u equal x. I mean e to the x. And then we'd make our substitutions. This would be a 2u squared. This would be a 5u minus 3 equals 0. I believe this is going to factor the exact same way as the other one. Oh, is this the exact same one? I remember, I think in period 6, I figured out it was the exact same. So I'm not going to do this twice. They're literally the exact same question, which means I can skip it. Exclamation point. Ay, ay, ay. Same as 32. Okay, we're not doing it. Moving on. So number 3. Is this guy different in a meaningful way? Doesn't look like it. So we'd make a u substitution again. You'll go ahead and let u equal e to the x. Then this will become u minus 2u to the negative 1 equals 1. Multiply through by u. That'll give you u squared. This will become u, so it'll be minus u, and then minus 2 equals 0. That's looking factorable to me. U minus 2, u plus 1. So that's telling me that our u value is equal to 2, which, oh, by the way, u is equal to e to the x. So that tells me that x is just the ln of 2. So there's an answer. This guy, however, gives me a u that equals negative 1, which if I set that equal to e to the x, and if I try to solve by taking the natural log of both sides, I do get an expression that is undefined. So throw that out. And again, solution set means you better use set notation. It'll be ln of 2. And I don't care what notation you use, honestly. The green is better. All right, I think a few questions back, I said there were 2 ways to think about how to get rid of this. And then I proceeded not to tell you the other way. So let me remind you, if you haven't fully understood how we're dealing with this negative exponent, then thinking about it like this could be really helpful. The negative just wants you to do the reciprocal, right? So this is 1 over e to the x. And just expressing it like that can make it really obvious why we're distributing through by e to the x. We are doing what we've always done. We're multiplying through by the LCD. In this case, it's e to the x. So when I multiply e to the x by e to the x here, I keep my base of e, and I add the powers. That's why I'm getting 2x. When I distribute here, they cancel, okay? So I just literally get whatever's in the numerator, which in this case is 1. And when I distribute it over to the 6, I get an e to the x that has a coefficient of 6. I don't really need parentheses here, but I'm going to use them anyway. All right, hopefully that's a little helpful. And maybe that clears up, if there's any confusion about the others, that'll clear it up. So this is now e to the 2x minus 6 e to the x plus 1. I'm going to forego the u substitution this time and just do this one directly as well. E to the 2x is essentially e to the x squared. So if I go to factor, it'll be an e to the x times an e to the x. And, okay, stupid me. Yeah, we can't factor. There's obviously no way to get factors of a 1 that make a 6. So forget that I ever tried to factor. So we would have to use quadratic formula, and that means we are essentially just solving a u substituted equation. We would treat this, think of this as a u squared minus 6u plus 1. So that, of course, gives me a u that equals negative b, so positive 6 plus or minus 36. I'm not doing the same problem again, am I? Nah, just feels pretty similar. Okay, so it'll be 36 minus 4. So that'll be 32 all over 2. So this will be 32, which is 16 times 2. So this will be 6 plus or minus 4 root 2 all over 2, which means it's going to be 3 plus or minus 2 root 2. So the question is, who's bigger, 2 root 2 or 3? If you don't have a calculator handy, then you might take your 2 root 2, turn the 2 into a root 4, and then combine these back together to see that it's a root 8. Root 8 is less than 3 because root 9 is 3. So root 8 is less than 3. So that means we have another one where both of these, whether I'm adding or whether I'm subtracting, the result will be positive, which means when I go to take the ln, they will both yield actual solutions. So I'm just going to cut to the chase. This here, combined with the fact that u is e to the x, is telling me that the x values are nothing more than the ln. And this time I won't break it into 2. I'll leave it as the 1 using the plus or minus symbol, because I think that's fine. So I'm still getting 2 solutions. At first glance, it looks like there's only 1 solution, but of course the plus or minus means there's 2 different solutions there. And I don't like this. Get rid of that. Okay. There's another. All right, so this one's good. And we kind of need to do this one 2 ways. So method 1 is kind of a special case. And method 1 is really only going to work for us because this time that exponent really is exactly twice the other one. So we can mimic that quadratic equation deal, x squared, x constant. We can mimic that because this thing really is exactly twice this, but that doesn't always happen. You could have an x plus 1 and the other one could be 2x plus 7. And then you'd have to use method 2, which is going to be for us more general. I want to call it that. So for this, you could just factor out the 2 and you would get 3 to the x plus 1 just times 2, or pulling that out squared. And then it's minus 4, 3x plus 1, and it all equals 0. So we can see that we do have, essentially a variable and then that same variable squared. So I can make that u substitution letting u equal, and this is slightly different, but it would be 3 to the x plus 1 instead of just 3 to the x. I can incorporate the x plus 1 as my whole power, and that'll be u. That'll turn this into a u that is squared minus 4 u's, and it equals 0, which means I don't have a heck of a lot more to do. I don't need quadratic formula or anything. I just factor out the u, and I get u minus 4 and u, telling me that u equals 0 is a solution, and u equals 4 is also a solution. But of course, if this is 3 to the x plus 1, our solution strategy here is still to take the log base 3 of both sides. So we would get log base 3 of 0 equals x plus 1. Now I said you couldn't take the log of a negative, and well, you can't take the log of 0 either. So this also is undefined. So even before we bother finishing for x by, subtracting 1, before we even bother doing that, we know we're done. There's not an answer here. It's extraneous. But the 4 is fine. If this is equal to 3 to the x plus 1, then take the log base 3 of both sides. This time you get log base 3 of 4, and that equals x plus 1. So you subtract 1 from both sides, and you get the log base 3 of 4 minus 1, and that equals x. And so that answer right there is fine. But as we talked about before, there is somewhat of an expectation that you rewrite the 4 as a 2 squared and then apply power rule. So out pops a 2, and what you really have is 2 times the log base 3 of 2 minus 1. So that's that for that. That's method 1, though. So how did method 2 work? Method 2 is the one where we have to spot this. If we have, some base to a power, I think this is backward from what I normally do, but multiplied by the same base but to a different power, I think everybody always remembers that the rule for this is you keep the base and you add the powers. But what people don't do is they don't recognize that you can do that rule the other way. If you've got just an exponential where there's a sum in the power, you could split that to 2 separate exponentials, and that's helpful for problems like this. So that's what we're doing. So we're going to take the 3 to the 2x plus 2 minus 4 times 3 to the x plus 1 equals 0. And what we're going to do is we're going to split it according to that rule. So this exponential could become 3 to the 2x multiplied by 3 to the 2. And of course, those would go back together and become 3 to the 2x plus 2. So that move here where we kind of expanded is a completely legal move. Now we've got minus 4. This guy has to break down too. So we'll keep the 3 to the x, and we'll multiply that by 3 to the 1, and that'll equal 0. And then what happens is these factors here that are just your constant base to a constant power, of course, just become a constant. That's just a 9. So that becomes the coefficient, 9 times 3 to the 2x. Here you've got a 4 and a 3, and they'll just combine and be a 12, 3 to the x, and that equals 0. So now we see we could do our u substitution and go from there. So we will. This will be 9u squared. This will be 12u. So from here we factor like always. There is no constant on our quadratic, so we just factor out the u, just like we did over here. When you had just a quadratic and a linear, you just factor out the u. That's easy. So here our greatest common factor is 3u. So if I factor out 3u, then I'm left with 3u, just minus 4. So for u, we get the same solution out of here of 3, but over here we get a different solution. We get a solution of 4/3. which is going to be fine because when we set that equal to e to the x, and we take Chihuahua, not e to the x, 3 to the x. So if we tried to solve this again, it's going to be extraneous. We're going to end up with log base 3 of 0, which is undefined. But over here, we get log base 3 of 4/3. And again, I've been pushing pretty hard for this recognizing equivalent forms. So look, over here, I got this answer. Over here, I got this answer. And y'all should be nervous thinking, oh my God, old Mr. F screwed up again, because obviously I should have got the same answer, but no, this is clean upable. This is a quotient, isn't it? So break it down. It would become the log base 3 of the numerator minus log base 3 of the denominator. And then this is a power. 4 is really 2 squared. So we can express it as 2 squared, pull out the 2, and now you're right back at 2 times the log base 3 of 2. And oopsie daisy, log base 3 of 3, that really is just 1. So we do have exactly the same answers right down to the button. So every bit is the same. And so you do need to be aware of both methods, because sometimes you'll get lucky and you'll be able to use this method. And what do I mean? Well, you'll be lucky if, why is this not scrolling? Okay, you'll be lucky if this power is exactly twice this power. And like I said, it just won't always be. One of the examples we did in class was not like this. So you probably are going to want to make sure that you know the general method where we break these exponentials apart, generating coefficients, and solve from there. This is the more powerful approach because this approach works no matter what. Okay, so I guess I'm done, right? That's the whole day 9 homework. So if this was interesting or if you learned something, please like and subscribe. See you later.